Hello everyone, greetings. Welcome to the course Mechanics of Road Vehicles. We are in the lane of CO number 3. Compare the characteristics of different types of governor. In our previous session, we have discussed about the objective of governor, construction and working, classifications of different types of governors, terms we are using to characterize the governor, and the characteristics of what governor, analyze the characteristics of porter governor. Now we are about to analyze the characteristics of Proell governor. In the analysis of porter governor, we just made a construction of porter governor arrangement. The difference between the porter governor and Proell governor was only the central load will act on the sleeve in porter governor. In what governor, there is no central load act on the spring. So that the porter governor called as dead weight governor. In the central load, half of the load will act on the left side portion of the governor and half of the central load act on the right side portion of the governor. For analysis, we just took one side of governor. Here we took for left side in our account. On the fly ball, there are number of forces may act. We just made a free body diagram of fly ball here. There was centrifugal force, self weight of ball was in downward direction, T1 force because of upper arm and T2 tension because of lower arm. We just resolved this tension of upper arm here and tension of lower arm here. We resolved two tensions into four forces, like two y direction forces and two horizontal direction forces. T1, T2 was converted as four forces. These forces are again resolved. To find the characteristics of porter governor, first two force members were selected, but there was no two force member, so that we gone for three force member at the sleeve point here. This point has three forces, that is one tension in this direction that is revolved into two forces, like vertical direction force and horizontal direction force, and it has a half of the central load act in downward direction because of gravitational force. We just resolved this. We got T2 equal to mg2 cos beta. And the forces on fly ball was analyzed. We got T1 cos alpha equal to caps mg by 2 plus small mg. Here caps m indicates that central load mass. Small m indicates the mass of fly ball. And finally, by resolving of forces and number of characteristics and the assumptions, we got n squared equal to 895 by h into mass of ball plus central load divided by 2 into 1 plus q divided by ball mass. This is what the relationship between speed of rotating masses and height of the governor. This is the characteristics of porter governor. It indicates that at this speed, maybe any RPM, the governor height will be like this. With the use of this equation, we can find the RPM if you know the value of h. If you know the value of speed of governor, we can find the height of governor here. We are in unit control mechanism, about to discuss the characteristics of Proell governor. As discussed in Port Governor, we have number of notations to be used in Proel Governor 2. It has ball mass small m, weight of the ball small w, mass of the dead weight or central load caps m, weight of the dead weight caps w, angular velocity omega, and centrifugal force Fc, and we have main part the differ between Porter and Proel Governor, that is eccentricity. To analyze the characteristics of any governor, we can go for two approaches. First one is analytical method, second instantaneous center method. In analytical method, we only have to make number of equations so that we can easily find the relationship between speed and height of governor. In instantaneous center method, it comes like a graphical method. We have to find the instantaneous point where the equilibrium we get zero. Before analyzing the Proel governor, we have to understand the arrangement or construction of Proel governor, what differs the Porter and Proel governor, since it two governors comes under deadweight category, so that the Proel governor should have the central load around the spindle. The weight may act on the S1 and S2 points. Half of the central load will act left side and half of the central load will act right side. But the Porter governor also has same thing. But what differs the Porter and Proel governor? We have to go for that. So as discussed, there will be some central load act on the sleeve of the governor, and in Porter governor we know that flame ball will be attached at the connection point of lower and upper arm. This is upper arm and here lower arm. At these connecting points we have flame ball in Porter governor. But in Proel governor we provide some eccentricity from this connecting point at this level, this distance, we call it as eccentricity. We just provide the eccentricity to the fly ball, it comes here. Instead of fixing the fly ball at the center or connecting points of upper and lower arm, we are going for the eccentricity provided for attaching the fly ball on Proel governor. This eccentricity makes the characteristics of Proel governor, which differs the Porter and Proel governor, and the speed height relationship. This distance we generally mark it as G. In an analysis of Proel governor characteristics, our first step is to find the instantaneous center point. At this point, the governor will be in equilibrium position. We are able to find that. First, we have to make a free body diagram of upper and lower arm. Upper arm makes an angle of alpha and lower arm makes an angle of beta. The eccentricity maybe I indicate as G as discussed. There may be some sort of half of the central load will act at this point. We mark this point as S1 and S2. I just take this point as S. At this point, half of the central load will act or dead weight will act at this point. The dead weight load we make it as W. So half of the central load will act, so that I take it as caps W divided by 2. And then we have to go for the forces act on the fly ball, so that the central or centrifugal force acts away from the spindle. We know that just here too we assume the spindle moves, the sleeve moves upwards, so that the balls move away from the spindle. Like if this ball is here, if spindle moves upwards, the ball will move like this. Actually, because of increase of speed, the centrifugal force will increase so that the ball will move away from the spindle so that the sleeve will move upward. This is what the current concept. So now the centrifugal force will act at the center of the fly ball. Actually, the centrifugal force is away from the spindle or central axis of spindle, and this fly ball has its own weight which will be in downward direction. We just take a fly ball weight as small w. Now we have to calculate the instantaneous center point, so that I just extend this upper arm like this. After that, we have to make horizontal line from point. Yes, at this point, sleeve point, we have to make horizontal line like this, so that it meets at one point. This point I take it as instantaneous center point, and we have sleeve point. Yes, I mark this point as F and ball point as B. If you look at this place, it looks like triangle. Actually, this extended line makes alpha angle with horizontal line. So I just take this extended line makes alpha angle with horizontal line, so that I make horizontal line here. At this point, I take it as point M. Now it's look like two triangles. This upper arm extension line makes alpha angle with horizontal line. Lower arm makes beta angle here with horizontal line. So the opposite angles are equal. Here too we get beta angle. So this upper arm extension line makes alpha angle here. Lower arm line makes beta angle here because of the opposite angles equal. After making the free body diagram of the upper and lower arm, we can go for the resolving of forces. Now we know that there are two forces acting on the ball. One is centrifugal force, it is in left hand direction, weight of the ball in downward direction, half of the weight of the sleeve in downward direction at the point of S. Now we have three forces here. We need not to consider the tension acting on the upper and lower arms, so that we can easily calculate or resolve the forces. Now we have to take a moment at any point of this arrangement at the triangle here. You can take moment at point I or at point M or at point S. Now I am going to take moment at point M. Now we have only three forces, so that we can easily calculate or easily find out the moments at about point M. Now think, Fc is an horizontal force, so that the vertical distance will be in vertical direction. The distance between point B to M, I just take it as Bm. So the moment because of Fc is equal to Fc into Bm about point M. Fc into Bm. I take anti-clockwise direction as positive. Second force is weight of the ball. It is in downward direction, that is vertical direction. The vertical distance is about point M Im. Because it is downward direction, so the vertical distance will be Im. It is clockwise direction, I just take it as minus. Third force is caps W by 2, the vertical distance of this load is I to S. It is also in clockwise direction, so I take it as minus W by 2 into IS, which is equal to 0. Now we have to resolve these forces. Fc into Bm equal to, I just bring these minus forces to right side to make it positive. So small w into Im plus caps W by 2 into Is. So that Fc equal to small w Im by Bm plus caps W by 2 into Is by Bm. I just bring Bm to right side. Now you can look at it, Im by Bm, here Is by Bm. Now look, this triangle makes alpha angle in a distance Fm. This triangle makes beta angle, here it is in Fm and Ms. We have to make Im by Fm and Ms by Fm, so that we can go for tan alpha like that, because opposite divided by adjacent. Im is the opposite side of alpha angle, so adjacent is Fm. So tan alpha equal to Im divided by Fm. We can say if Fm is here, we can easily go for tan alpha. Tan beta equal to Ms divided by Fm. Here you can note it is Is. Here it is Bm. If it is Fm, we can easily calculate. So that Is equal to, we can say Im plus Ms. Is equal to Im plus Ms. So first we have to simplify that. From diagram, we can say Is equal to Im plus Ms. Fc equal to small w Im by Bm plus caps W by 2 Im by Bm plus Ms by Bm. Here Is equal to Im plus Ms. We can note tan alpha equal to Im by Fm. Tan beta equal to Ms divided by Fm. Here you can see that instead of Fm we have Bm. Here instead of Fm we have Bm. We have to make it as Fm, so that I just make Im by Bm commonly. We have small w plus caps W by 2 plus small caps W by 2 into Ms by Bm. This is equation number 1. As discussed, instead of Bm, here if we have Fm, we can go for Im by Fm equal to tan alpha. Im by Fm equal to tan alpha. Instead of Bm, here if we have Fm, Ms by Fm is equal to tan beta. So we have to make Bm as Fm, so that we just multiply Fm by Fm on both sides. If you multiply Fm by Fm, here it gets striked out. So Fc equal to, here if you multiply Fm by Fm to the whole term, we get Im by Fm into Fm by Bm. We can make it like this. Small w plus caps W by 2 plus small w by 2 Ms by Fm into Fm by Bm. If you strike out this, we get Ms by Bm. Here if you strike out Fm by Fm, we get Im by Bm here. So we get the same answer. For our simple calculation, we just make Fm by Fm multiply on both sides. Here we get Fm by Fm equal to 1. So I just make it as Fc. Now we know that Im by Fm equal to tan alpha, and ms by fm equal to tan beta. I just take commonly fm by bm. So fm by bm equal to small w into im by fm plus w by 2. I just make this w by 2, this w by 2 commonly im by fm plus ms by fm, because this im by fm will be like this here, ms by fm into fm by bm here. So here it becomes im by fm plus ms by fm. I just simplified this equation here. Instead of fm by bm, we have im by fm equal to tan alpha and ms by fm equal to tan beta. I just make here im by fm equal to tan alpha and ms by fm equal to tan beta. If we substitute this, we get fc equal to fm by bm into small w into tan alpha plus caps w by 2 into tan alpha plus tan beta. We know that im by fm equal to tan alpha, here ms by fm equal to tan beta with the use of this triangle. Again, if you resolve this equation, fc equal to fm by bm, I just take tan alpha commonly. So that tan alpha into small w plus caps w by 2 tan alpha 1, because we just took tan alpha outside of this equation, and plus tan beta by tan alpha. We know that for given assumptions as discussed in Protagoner, tan beta by tan alpha equal to q and tan alpha equal to r by h. We know that very well. Tan alpha equal to r by h, because this distance is r, here distance is h. The opposite side is r, here the horizontal side is, that is adjacent side is h. So tan alpha equal to opposite divided by adjacent, we get r by h. And tan beta by tan alpha equal to q, we just make it simple. Instead of tan beta by tan alpha, you can keep it like this. So fc equal to fm by bm. Instead of tan alpha, we can substitute r by h, small w plus caps w by 2, 1 plus q. Now we know that this is our equation number 2. fc equal to mr omega square. Small w equal to small m into gravitational force, that is mg. Caps w equal to caps m into gravitational force, that is central load mass into gravitational caps m into g. If we substitute these values in equation number 2, we get mr omega square equal to fm by bm into r by h, brackets open, small mg into g plus caps mg by 2 into 1 plus q. And if you bring mr to right side, because we need to find the speed, that is rpm of spindle or governor, so that I just keep omega squared in left side, we get fm by bm into, if you bring mr here, r and r striked out, so that 1 by h, 1 by m, I just splitted that into the equation mg plus caps mg by 2 into 1 plus q. This is our equation number 3. Now we know that omega equal to 2 pi n by 60. If you apply this value in our equation number 3, we get n squared equal to fm by bm 895 divided by h into small m plus caps m by 2 into 1 plus q divided by whole divided by m. I just give a value for phi, g equal to 9.81, phi equal to 3.14, we get the constant value as 895 by h. This is the relationship between the speed of governor and height of the governor here. In Porter governor, we get only this term 895 divided by h. But in Proell governor, we have extra this equation. It is multiplied with Fm by Bm. It makes the difference between Porter and Proell governor characters. It completely affects the relationship between the speed of governor to the height of the governor. This is our equation number 4 and our final answer. This course outcome has learning outcomes and some sort of specific outcomes. Our learning outcomes are analyze the characteristics of Watt governor, analyze the characteristics of Porter governor, analyze the characteristics of Proell governor, and analyze the characteristics of Harder governor. This analysis of Watt governor has to be done in analytical method. We have already gone for analytical method solve of Watt governor. We just found n squared equal to 895 by h. Now you have to solve a problem by your own. I just mark it in red color. Analyze the characteristics of Porter governor can be done in two approaches. One is analytical method, another one is instantaneous center method, and then we have to go for problem. Analytical method is already completed. Now you have to done instantaneous center method and problem by your own. In analyze the characteristics of Proell governor, we have done instantaneous center method. Now you have to go for analytical method and problem your own. Analysis of Hartnell governor and problem has to be done by your own. These are all your works. Problem for Watt governor, instantaneous center method and problem of Porter governor, analytical method and problem for Proell governor, and analytical method problem for Hartnell governor. You have to do that as an assignment. Thanks for kind listening.